Good morning, good afternoon, good evening, wherever you may be in this part of the world. Welcome to another session of my presentation series, and this time the topic is electrical power generation utilizing a pump storage energy system. My good name is John Kweku Amotu. I've been a professional electrical engineer for the past 31 years, and I'm based in the United States of America. Now let's talk about some logistics here, and basically, if you like my presentation, don't forget to select the like button, and also this is another like button that you can select if you see either of these on your screen. You can select them. Then don't forget to share that knowledge. Also, this is the subscribe button, and that is purposely for my YouTube channel. The name of my YouTube channel is Working Happiness, Talking to the Engineer, right? Okay, so this has tons of presentation material that is good for a young engineer, developing engineer, in between, starting your career to mid-level engineer, mid-career level engineer, and also experienced engineers and consulting engineers. There are tons of presentation materials that can help you to refresh yourself. Okay, so I think I did make mention of this logistics in YouTube, and basically I will re-emphasize on it. This is the name of my YouTube channel, Working Happiness, Talking to the Engineer, and it has tons of presentation materials. Basically, that will help you in the power system area. And for you to be able to subscribe to this channel, you need a Gmail account with Google, right? Don't forget. Without that, you won't be able to subscribe. Okay, so if you don't have it, go ahead and create a Gmail account. Then you should be able to subscribe to this channel. Okay, so re-emphasizing and rephrasing. If you like my presentation, don't forget to select the like button and don't forget to share the knowledge. Okay, so now let's talk about the pump storage, the basics of the pump storage. Okay, so consider a hydro plant, right? So what you are seeing over here is a hydro plant that basically generates electric power utilizing water, right? And it's considered as a renewable, right, energy. Okay, so the dam should be on this side, right? Okay, so you have water that has been dammed, to create that energy within that dam. So this could be like, let's say, about 1 mile to 2 miles of dam water. So that itself is what? Potential energy, right? Based on the heights, weights of the water, right? Okay, so what is done is basically you have piping that is connected to this dammed water, right? That has a lot of energy that comes downstream, right? This is called penstocks. So the piping is called penstock. So you can have about 2, 3 piping. Also, depending on the number of hydro generators that is in this hydro plants, you can have about 6 to 10 piping that comes downstream. So basically, the water comes down based on the energy that is stored in this dam. And like I said, this dam can be several miles, 1 mile to 2 miles. So think about it, that enormous amount of energy. So with this piping, it comes down, so you see that the hydro generators are located over here. So let's talk about the hydro generators, how they look like. Okay, so on top, they are vertically mounted, right? And this is the generator, right? And below that is the turbine side, right? So this generator has a shaft, right? And this turbine has a shaft. And these shafts are coupled together, right? Okay, so this piping that comes from here, right, from the stored energy in the dam, basically impinges upon the turbine blades, right? So once it impinges upon it, it starts rotating, right? So think about it, that amount of energy, you have a 1 to 2 miles of stored energy. And also look at the height. Think about the height of this volume of water. So let's say about half a mile in height. So once that water rushes down the penstock and hits the turbine blade, it starts rotating. And once it starts rotating, basically that's rotational energy, right? And once the shaft of this turbine is coupled to the shaft of the generator, right? The generator shaft also starts turning. So the rotor of the generator starts turning and gradually start building um, basically voltage at the terminal, right? Based on the excitation system of the generator, basically building that magnetic field around the rotor of the generator and to be able to induce voltage into the stator that can help to build the required voltage at the terminal, usually by about 13.8 kV. Right. So these turbine generators for hydro are basically, they are very slow. They turn very slow because they are salient pole, something they call salient pole machines, right? So the rotor basically has poles wound around it, right? So comparable to cylindrical rotor machines that basically turns at a faster revolutions per minute, right? Okay, about 1800, right? 1800 or 3600 RPM. That is for cylindrical synchronous generators, right? Comparably, for salient pole hydro generators, it turns at a very slow because of the number of poles, right? Cylindrical machines have 2 poles, right? And number of the speed in revolutions per minute is equal to 120 over F over the number of pole pairs, right? Okay, so as you can see over here, 2-pole machine leads to a faster speed, right? Comparably with the salient pole that is utilized in hydro, it has a lot of poles. So let's say if you have a 100-pole machine, right, the speed, if you have 100 over here, then if you have a frequency of 60 hertz, right, the speed is very small. So that is why salient pole machines turns at a lower speed. Okay. So the reason why they call it salient pole is right around the rotor, there is something they call, these poles are mounted right around the circumferential surface of the rotor winding, right? So that is what basically builds the rotor winding. And basically its goal is, they call them amortisor winding, right? So this amortisor winding is basically what helps the generator to build the required torque, right? And also during fault conditions, basically it provides a damping condition to be able to damper, the fault transients. Okay, so now let's talk about the pump storage. So this is how the pump storage looks like. Okay, so remember I told you that if you have a mountain, if you have a hill that is in close proximity to a lake, it can either be a lake that is in close proximity. So as you can see over here, this is the lake, right? Or it could be a river, or it could be an afterflow or after spill, right? That is if water goes through, for a hydro power plant, if water has basically gone through the turbine, then the spillway, you can utilize the water in the spillway to pump back into this pump storage, right? Okay, so for this picture, they are utilizing a lake that is in close proximity to this pump storage, or it could be a river. So what it does is it has a motor, right, that basically pumps back the water to fill it to form a storage system, right? So think about it. this could be as deep as, let's say, half a mile. In the volume, it's a lot of volume of our water, right? Okay, so basically, a lot of concrete is utilized to basically build this pump storage so that it can contain this volume of water, because you don't want this pump storage to basically to break, right? And I think I've seen one or two instances where basically the pump storage system has failed. I think one of it's a utility in the Missouri area where basically, and it ended up flooding a whole town, right? So because of the amount of water. And think about it. If that amount of water is rushing down and the speed, it can basically end up, basically destroying the whole township, right? Okay, so because of that, a lot of concrete is utilized in building this and to contain that. And but the fact it also has other sealant that basically allows, for, and also measuring devices that measures basically the level of water, right? Basically, it has a level detectors that is basically sends signals to a central control room to be able to monitor the level of the water in the pump storage. And also, if there are leaks, right, it is able to, there are sensors all around that is able to basically send signals about leaks so that it can be repaired. Okay, so like I told you that this is basically just like a dam, right? But it is a dam that is in a mountain, right? So this mountain, the top of this mountain has been carved to form the storage, compared to a hydro plant where basically a dam is built, several miles, like let's say 1 to 2 miles, right, to contain that volume of water. But in this case, we are utilizing a hill or a mountain to perform, that purpose. Okay, so you have motors over here, right, that pump the water up the hill, okay, to basically fill up this storage system, right? Okay, so on this side are the generators, right? Let's say 1, 2, 3, 4, right? And you have a piping that comes from the top, right? That comes from the top, right? So, like I indicated, this pump storage system is used during peak shaving. Peak shaving means that it is utilized when demand is very high, and you can see that, during summertime when, let's say, summer peak loads are very high, and when everybody is utilizing air conditioning system, because of the high summer temperature. So the summer peak loads are, and sometimes you can have emergency loading, right? Let's say if the transmission network, if let's say a utility should lose a generator due to a fault, right? And basically it can call for that demand of energy. So that is when they release this water over here, so that this hydro generators can start turning to generate the required power that is needed. So at the same time that all the water is released, you have motors that pumps it back in a complete cycle, right? Okay, you can have basically a closed loop cycle or an open loop cycle. Okay, a closed loop cycle is when it basically the water goes through the penstock into through the hydro generators, right? It goes back. You have motors that pump it back. So that is a closed loop. An open loop is when it comes through. It's not pumped back until the pump storage system is empty. Then later on, they can, at their own discretion, they can basically pump it back to fill this storage system. Next is another beautiful picture of how the pump storage system looks like. As you can see, very, very beautiful, right? So as you can see over here, this is, a small hill, or, where basically, it's being carved, it's been excavated, right? many, I'll say this one could be like about quarter of a mile, right? Deep, where basically a lot of basically concrete has been utilized to form all the peripheral surface, all the way from the top to the bottom, right, to be able to hold that amount of volume of water, right? So, as you can see over here, this one is basically in close proximity to a hydro plant, right? So basically, the pass-through water, or basically spill water that basically goes through the hydro plant is pumped back through, you have, motors that pumps the water to fill out this reservoir. And like I indicated that, this pump storage system is utilized, during emergency, during peak shaving. Peak shaving means that I'm shaving off the amount of peak load that is required. Okay, so remember I made mention that for the pump storage system, you have an open loop and closed loop. Okay, so for the open loop, right, this is the reservoir, right, that is located in the mountain area, right, that has been carved, and basically, the large reservoir, maybe about half a mile, quarter of a mile to half a mile deep, right? Okay, so, and this is the penstock I was talking about, is the piping, right, that is connected to this storage system, right? And this is the generator, vertically mounted generator, right? Okay, so once the water comes through this piping, it goes through the generator, it hits the turbine blades, right? The turbine blades start rotating, right? And once the turbine of the hydro generator is connected to the generator shaft, basically the generator also starts rotating. And the extension system basically is fed to the winding of the generator rotor, and basically it builds the magnetic field. And that magnetic field, as the rotor of the generator starts rotating, that magnetic field basically cuts the stator winding. There's a conductor there, and it induces that voltage. So it starts building that voltage until the required voltage is built, let's say 13.8 kV, or let's say 21.3 kV. Those are typical terminal voltage for hydro generators. So once the water goes, passes through, the turbine, it basically comes into a lower reservoir, right? Right. On the other hand, for the closed loop, right? Okay, you have water coming through the penstock, the piping. Yeah, this is the piping, right? So think about it. That lot of energy, going through this, potential energy penstock tunnel, right? Then this is the powerhouse, right? That has the generator, right? This is the generator and the turbine, right? Okay, so it goes through A, then it is pumped back, right? It is pumped back, from the lower reservoir. This is the upper reservoir, this is the lower reservoir, right? It is pumped back. So that basically forms a closed loop, right? Okay, so the generator starts generating electric power, and basically it goes through a step-up transformer, then up the transmission network. So that is how pump storage system basically generates electric power. Okay, so now let's talk about my YouTube channel, right? Okay, so if you like my presentation, don't forget to select the like button, and don't forget to share. And this is my YouTube channel, Work and Happiness, talking to the engineer. So there are tons of presentation material there. Okay, and you can subscribe. For you to be able to subscribe, this is the subscribe button, right? You need a Gmail account. Okay, this is a Google account. Okay, that is email. You can create a Gmail, and that will help you to be able to subscribe to this YouTube channel. With that comes to the end of my presentation, and thank you so much for your listening ears, and look out for more presentations from my end. Okay, thank you.